Lab 3. The purpose of this lab is to use the fundamental physics principles to estimate the mass of the black hole. The procedure is: first identify the system, which is the star, then find forces from the model and calculate the net force on the star, and I've listed the interactions, which is gravitational force of the black hole on the star. Lastly, I'm going to estimate the mass of the black hole. This is the preview. Fundamental physics principles used. First, I used Newton's universal law of gravitation. Then I used Newton's second law of motion. Lastly, I used the parallel and perpendicular parts of dp over dt. The given informations were the mass of the star, which is 2 times 10 to the 30 kilograms, delta t, which is 1 day, and F net, which is only due to gravitational force by the black hole. I generated a unique star trajectory key to my email address by replacing the dummy address with my Georgia Tech email address. Then I modified the star's mass and delta t, which is right over here, to match the given information. The equations for the rest of the part was edited using Newton's second law. P initial equals star's mass times velocity initial, P final equals star's mass times velocity final. Then delta V was V final minus V initial, delta P was P final minus P initial. dP over dt was delta P over delta T. F net equals delta P over delta T based on Newton's second law. And I've calculated the P hat, which is P initial divided by magnitude of P initial, the magnitude of dP dt, which is magnitude of P final minus magnitude of P initial divided by delta T. dP dt parallel was equal to d magnitude over dt times P hat. Then F net parallel was equal to dP dt parallel. F net perpendicular was equal to dP dt perpendicular, which was calculated using dP dt minus dP dt parallel. I calculated the magnitude of radius squared by finding the magnitude of the star's position squared. In the original code, the position for the black hole is 0, 0, 0, which means the star's position equals the radius between the star and the black hole. I rearranged Newton's gravitational equation to calculate the mass of the black hole. The mass of the black hole equals magnitude of F net times r magnitude squared over g times star's mass. The arrow scale and 3 arrows were used to represent the F net parallel, and F net perpendicular, as you can see right over here. F net that I got from this experiment was 7.82974 times 10 to the 28 newtons. F net parallel was 1.26495 times 10 to the 28 newtons. F net perpendicular was 7.73374 times 10 to the 28 newtons. And average mass of black hole was 9.46 times 10 to the 33 kilograms. And I've used the equation average in spreadsheet to calculate the average mass of the black hole. The mass of a black hole is about 2 times 10 to the 30 kilograms, which is around the same as my calculation. And so the experiment looks good to represent the actual model. The magnitude and direction are the same for the net force and its parallel and perpendicular components compared to the rate of change of momentum and its parallel and perpendicular components. But the meanings are different. A force can cause a change in momentum, but a change in momentum cannot cause a force. F net basically means the sum of all forces acting on the star. dP dt is the change in momentum of the star, and its parallel component means the change in magnitude of the momentum, and perpendicular component means the change in direction of the momentum. It is not possible to find the value for the mass of the new black hole because the motion for the observed star remains unchanged and is only affected by the gravitational force. This means when we calculate the mass of the new black hole, it is going to result in the same mass as the original black hole. Finally, conclusion. The computational model that I used is a reasonable representation of the actual data. And the average mass of the black hole that I calculated using the F net was 9.46 times 10 to the 33 kilograms.